this video, we're going to be talking about networking devices. This is a two-part video. In this video, we will be talking about hosts, IP addresses, and networks and subnets. First, let's talk about hosts. Hosts are any device that can send and receive traffic. Traffic is nothing but data. For example, your computer is a host, your laptop, phone, printer, servers, all these are considered hosts because they send and receive data. We also live in the Internet of Things age, which means anything that can connect and communicate through the Internet is considered an IoT device, which means devices like smart TVs, smart speakers, smart watches, smart thermostats, even smart refrigerators. All of these are sending and receiving data, therefore can be considered hosts. Why this is important? Because all these devices follow the same rules for how they communicate to the Internet. There are two types of hosts, clients and servers. Clients initiate or send a request for information, and servers respond to those requests. So when this computer or this client wants to access a website, which is stored on this server, and this client wants to access that website, it will send a request to the server, and then the server will respond back with the right files like the HTML, CSS, images, etc. that make up the website. The server will send those back to the client. A server is nothing but a computer with software installed that knows how to respond to specific requests. You can turn any computer into a server by simply installing the server software. Now, let's talk about IP address. IP address is like a mailing address or home address for each host. Everyone has a home address, and when you send someone mail, you put the address on the mail and send it. Similarly, every device has an IP address to communicate on the Internet. So if another device wants to talk to this device, it will put the IP address and send and receive data packets. When a host sends data, it sends it in an envelope. We call this envelope a packet. Each packet is included a label with a source IP, the IP where it's the sender's IP, and a destination IP, the receiver's IP. This host receives the packet and then removes the label and processes the request or the data. If the host needs to respond back, it repeats this step. The host on the left creates a packet and attaches a label by switching the address. So it will now put its IP as the source address and the destination IP as this computer's IP. Every packet on the Internet will have this label with the source and destination IP addresses. An IP address is just a series of 32 bits. So what does it mean by 32 bits? A bit is just either 1 or 0. So every IP address is just a combination of ones and zeros. So over here we got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 digits or 8 bits. And we separate, and there's 8 bits over here, there's 8 bits over here, 8 bits over here. 8 plus 8 plus 8 plus 8 is equals to 32. So the IP address itself has a combination of 32 bits or 32 ones and zeros. We separate the 32 bits into 4 sections of 8 bits each. When we put 8 bits together, we call it an octet or a byte. And it's very simple to convert this binary into this decimal form. This is the form that humans understand, and binary is the form that computers understand. I'll make another video to explain how to convert between these two forms. For now, just take my word for it that this combination of bits converts into 10, this combination turns into 255, this combination turns into 0. When assigning IP addresses, there is a hierarchical structure. For example, let's consider this sample corporation called Nova Corporation, which owns all the IP addresses starting from 192 and anything that comes after them. This is the IP address of the entire network. The corporation has offices in New York, London, and Tokyo, and each office divides this IP address. So the New York office has 192.10.xx, London has 192.20.xx, and Tokyo has .30. Within each office, there are further subdivisions. So, for instance, the New York office has different teams, the sales, engineering, and production. And each of it, the department, has its own dedicated IP ranges. So, sales team has 192.10.22.x, and the engineering team has 192.10.33.x, and same thing for the production team. This hierarchical structure helps pinpoint where a particular device is located. For example, this is an IP address. Now, to find out where this IP address is, we'll just read it. Let's break it down. So the 192 means that it's part of the Nova Corporation. 20 means that's part of the London office. 33 means that's part of the engineering department. And the 9 means that some device in the engineering department that has this IP address. So if we zoom in, we just have to go look, and this is the engineering department's IP network, and we see that this device is the one that we're looking for. This breaking up of IP addresses into hierarchical structures is done through a process called subnetting. Subnetting is the process of dividing a network into smaller networks. So what is a network? All of these devices in this department it exists in what we call a network. A network is just a system that transfers data between devices. At its core, anytime you connect two devices together, it forms a network. In the past, to move files from one computer to the other, you would literally have to physically walk to the other computer and transfer the files manually. Now, through a network, these computers can share data automatically. Think of it this way. There's two houses. I need to deliver a message from this house to this house. Before telephones, you would have to walk to this house to deliver the message. But with telephones, you can just call the other house instantly and deliver the message. Similarly, a network is like having telephones for these devices, making communication faster and easier. Now let's talk about subnets. A subnet or a subnetwork is a logical subdivision of an IP network. So here we have a network, and it's been divided into this group and this group. Let me use an analogy to help you. Think of a network as a square. We can cut this square into 4 smaller squares. These small squares are what we call subnets. The cuts that are made to divide them into 4 squares is what we call subnet mask. We will talk about subnet masks in another video. For now, what you need to understand is that these small squares are the same thing as this big square, just smaller. So subnets are the same thing as this entire network, just smaller, and have more specific uses or contain a fewer number of devices compared to the main network. Now let's go back to Nova Corporation. The 192.x.x.x is the IP network for the entire corporation. This IP network is subdivided into 3 subnets, and each office's subnet is further divided into 3 smaller networks or subnets. This setup separates the network like this, as each subnet can be made for specific uses. For example, the engineering subnet might need more network usage, so we can build a network for this department in a way that supports their needs for more network usage. And we can build a network for the sales department to have less network usage, as they might not need it as much compared to the engineering subnet. The subnets help manage and secure the flow of data more efficiently and securely. This allows for better control, security, and performance management within a network. And all these networks and subnets connect to a central resource, mainly the internet. So whether you're working from home or any of these branches of office, All devices can communicate and share information seamlessly through the internet or the interconnected web of networks.